Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who likes to drift to sleep with quiet wonder, letting thoughts of distant worlds replace the noise of daily life. There's nothing you need to do now but rest. Let your mind grow still, your breathing slow, and your body light. Because tonight, we're not just closing our eyes. We're traveling far beyond our solar system into a realm filled with worlds we've only just begun to understand. From the first hints of planets orbiting other stars, to shimmering oceans, molten horizons, and quiet places where life might softly stir, we'll explore 100 sleepy facts designed to help you relax, unwind, and dream of the cosmos. We'll drift through stellar cradles and ancient suns, meet planets of glass and planets of twilight, and wander across the wide, star-filled gulf where new discoveries wait in silence. Each fact will be a gentle step deeper into the worlds beyond, a whispered invitation to let curiosity carry you toward rest. And if these calm explorations help you sleep, consider liking and subscribing. It helps other sleepy travelers find their way here too. Now, close your eyes, let your breath fall into an easy rhythm, and let's begin our journey through the exoplanets. Fact 1. A galaxy filled with secrets. Long before we ever named them, exoplanets drifted quietly in the dark, circling their distant suns with no witness but starlight. For most of human history, we looked up at the night sky without knowing that nearly every point of light held its own family of worlds. Yet the galaxy was already full, overflowing with planets of every shape, color, and temperature, each following its gentle path through the cosmic quiet. Today, we believe there are more planets than stars in the Milky Way. Some are warm and rocky, others are vast and cloud-soft, and countless more remain completely unknown. The idea alone brings a kind of peaceful awe, a reminder that the universe is richer and calmer than we can see. And just beyond this thought, another hidden world waits softly in the dark. Fact 2. The first hints of distant planets. The first signs of exoplanets didn't come from seeing them directly. They came from the faintest whispers in starlight. Astronomers noticed certain stars shifting ever so slightly, as if tugged gently by an unseen companion. These motions were tiny, almost imperceptible, like the slow sway of a lantern in a breeze. But the pattern was too steady, too rhythmic to ignore. Those subtle wobbles were the earliest clues that stars were not alone. Something orbited them, something massive enough to pull them side to side. It was a quiet revelation, unfolding not in a burst of discovery, but in the patient, careful recognition of a soft cosmic signature. And as we listened closer, another whisper in the starlight appeared. Fact 3. The stellar wobble. Every star with a planet experiences a gentle gravitational dance. The planet moves around the star, yes, but the star also circles a tiny point near its own center, rocking ever so slightly as its companion tugs on it. To us, light years away, this wobble appears as a subtle shift in the star's color, drifting toward blue as it moves closer, and toward red as it drifts away. This method, called the radial velocity technique, became one of the earliest ways we could sense the presence of distant worlds. It's like watching a boat bob on calm water and inferring the fish beneath it. Beyond this quiet motion, another soft clue was waiting to be found. Fact 4. The whisper of a dimming star. Sometimes, a star's light fades for just a moment, not enough to startle, barely enough to notice. But when that fading happens in a gentle rhythm, repeating with soft, steady timing, it can mean that a planet has drifted across the star's face. From so far away, we can't see the planet itself. We only feel its presence in the tiniest dimming, like a moth passing briefly in front of a lantern. This method, called the transit technique, has become one of the most powerful tools we have. With it, we can measure a planet's size, its orbit, and even hints of its atmosphere. A single, delicate dip in starlight becomes a doorway into an entire world. And after that first quiet shadow, a whole new era of discovery began. Fact 5. The birth of exoplanet science. The study of exoplanets is young, astonishingly young. Just a few decades ago, the idea of finding planets around distant stars felt more like poetry than science. But once the first worlds were confirmed, an entire field bloomed almost overnight. Telescopes were redesigned. Instruments grew more sensitive. The universe, which once seemed sparsely populated, suddenly became crowded with possibility. Early discoveries arrived one by one, like soft knocks on a half-open door. Each new world felt like a message from the cosmos, encouraging us to keep looking, to keep listening. And with every planet found, the sense of wonder deepened. We realized we were not just mapping stars anymore. We were uncovering homes. And from these beginnings, we turned our attention to where those homes are born. Fact 6. Clouds of cosmic dust. Every planet begins in a drifting cradle of dust and gas. Around young stars, these materials form vast swirling clouds, gentle, hazy veils illuminated by newborn light. Within these clouds, grains of dust collide and cling, gathering quietly over millions of years. There is no rush, no sound, only slow accumulation in the deep calm of space. These clouds are the first chapters of every planetary story. They hold the ingredients for oceans, mountains, atmospheres, and distant skies we may never see. And though these early moments are invisible to the eye, they are the soft foundation upon which every world is built. Just beyond those clouds, another step in the making of planets waits to unfold. Fact 7. Spinning disks of light. Around young stars, the leftover dust and gas settle into wide, graceful disks that slowly turn like cosmic potter's wheels. These protoplanetary disks shimmer faintly in starlight, their particles drifting in gentle spirals. Over time, small ripples form, places where matter gathers a little more thickly, as if the star is quietly shaping its future planets with soft, circular motions. From afar, these disks look almost like halos, glowing softly against the dark of space. They mark the beginnings of entire planetary systems, each ring a promise of worlds to come. And as the disk continues to spin, tiny seeds of planets begin to emerge from its glowing dust. Just beyond that slow rotation, the next step begins to take shape. Fact 8. Pebbles becoming planets. Inside these glowing disks, the tiniest pieces matter most. Dust grains collide gently, sticking together like snowflakes on a quiet winter night. Over thousands of years, these grains form pebbles. Over millions, pebbles gather into boulders, and boulders into mountain-sized bodies called planetesimals. Each one is a silent builder, adding its weight to the construction of a new world. The process is patient and unhurried, a soft layering of material in the dark. There are no explosions, no sudden leaps, just the steady pull of gravity guiding pieces together. Eventually, these planetesimals grow large enough to reshape their neighborhoods, sweeping up everything around them. And when they become massive enough, something even more remarkable begins. Fact 9. The gentle push of gravity. As young planetary seeds gain mass, gravity becomes their quiet sculptor. It pulls nearby material inward, allowing the growing world to gather more dust, more gas, more of everything it needs to take form. Gravity works slowly, like a calm tide drawing pebbles ashore. Each new layer settles softly onto the forming planet, smoothing it into a rounder, steadier shape. In these early stages, heat builds inside. The world glows faintly, with the warmth of its own making, a soft fire hidden beneath clouds of dust. Over time, the sphere becomes more defined, more solid, more certain of its place within its star's embrace. And from this gentle shaping, a fully forming planet rises quietly from the dark. Fact 10. Worlds in the making. As these young planets take shape, they carry with them the warmth of their birth. Their surfaces glow softly at first, like embers beneath drifting ash. Molten rock pools and shifts in slow, shimmering waves, and the air around them swirls with the leftover heat of creation. These worlds are not yet calm, but they are becoming whole, settling gradually into their orbits as their fires fade. Over millions of years, their surfaces cool and solidify. Crust forms, oceans may gather, and atmospheres begin to rise like early morning mist. Each world moves from chaos into quiet, preparing for whatever future its star will offer. And as these young worlds cool, the stars that guide them shine steadily on. Fact 11. The many kinds of suns. Stars come in many colors and temperaments. Some burn with brilliant white light, fierce and short-lived. Others shine gently, glowing in warm oranges or deep calming reds. Each type of star shapes the worlds around it, offering different possibilities for warmth, climate, and long-term stability. A planet's entire destiny often begins with the nature of its sun. Hot, massive stars may host planets scorched by intense radiation. Smaller, quieter stars may cradle their worlds in steady, nurturing light for trillions of years. In the soft diversity of starlight, entire families of planets find their rhythm. And among these many suns, one type glows with a particularly peaceful promise. Fact 12. Red dwarfs and quiet fires. Red dwarf stars are the gentle lanterns of the galaxy. They burn cool and dim, conserving their fuel with remarkable patience. Though small, they are incredibly long-lived. Some will outlast the universe as we know it. Their calm, steady light makes them some of the most promising cradles for exoplanets. Because they shine so softly, their habitable zones lie close in, allowing planets to orbit snugly, completing years in just days or weeks. Many of the most Earth-like candidates we've found circle these little suns, basking in their quiet warmth. Around them, countless worlds may drift in serene, enduring glow. And just past these peaceful flames, stranger kinds of stars wait to shape their own families of planets. Fact 13. Blue suns and harsh winds. While red dwarfs glow softly, blue stars blaze with intense, brilliant light. These massive suns burn fiercely, consuming their fuel quickly and sending out powerful stellar winds that sweep across space. Around such stars, planets face harsh radiation and unstable environments, making calm, Earth-like conditions unlikely. Yet these worlds exist, scorching, turbulent places, sculpted by the bright fury of their parent star. Because blue stars live fast and die young, their planets have only brief windows to form and settle. The result is often dramatic. Worlds wrapped in searing storms, glowing atmospheres, or winds strong enough to strip them bare. Beautiful in their severity, these systems remind us how diverse the cosmic landscape can be. And for some planets, there is more than one sun to navigate. Fact 14. Binary stars sharing worlds. In parts of the galaxy, two stars orbit each other in a graceful celestial dance. Around them, planets can trace sweeping paths that loop around both suns at once. These circumbinary worlds exist in perpetual choreography, moving through skies where twin dawns rise and twin sunsets fade. The light they receive shifts gently as the stars weave their orbits, creating rhythms unlike anything we know on Earth. Some of these planets remain stable for billions of years, nestled in safe distances from their paired suns. Others follow more complex routes, their climates shaped by the changing balance of light and gravity. Yet even in these dynamic systems, harmony is possible. And beyond these double suns, some worlds travel with no sun at all. Fact 15. Lonely planets without suns. Not every planet belongs to a star. Some worlds drift freely through the galaxy, unanchored and alone. These rogue planets may have been born beside a sun and later cast out, or they may have formed independently in the quiet darkness. Without starlight, their surfaces are cloaked in eternal night, illuminated only by faint internal heat or the distant glow of the Milky Way. Yet even these solitary travelers hold mysteries. Thick atmospheres could trap warmth, and hidden oceans might linger beneath icy shells. Though they wander without a guiding star, they move with calm certainty through the deep, silent reaches of space. And from these lonely wanderers, our journey returns to the worlds we've learned to find among the stars. Fact 16. The first confirmed exoplanet. The first truly confirmed exoplanet surprised almost everyone. Instead of orbiting a peaceful star like our sun, it circled a pulsar, the dense, slowly cooling remnant of a massive star that had once exploded. The planet itself was quiet, but its parent was anything but. Yet there it was, unmistakably tugging on the pulsar's rhythmic radio pulses, revealing its presence through gentle timing shifts. This discovery, made in the early 1990s, proved that planets could form, or survive, in places we had never imagined. It opened the door to the idea that worlds might arise under all kinds of conditions, even in the aftermath of stellar violence. And soon, after this unexpected beginning, stranger worlds began to appear. Fact 17. The early hot Jupiters. The next major discoveries brought even more surprises. Enormous gas giants orbiting so close to their stars that their years lasted only days. These planets, called hot Jupiters, were nothing like anything in our own solar system. Their atmospheres simmered under intense heat, swirling in giant clouds that glowed with reflected starlight. Astronomers had not expected such giants to sit near their stars. But there they were, unmistakable and bold in their behavior. Some puffed up from warmth, others whipped around their orbits at incredible speeds. These early finds taught us that planetary systems do not follow a single pattern. They unfold in countless configurations, each with its own rhythm and design. And from those surprising giants, our gaze soon shifted to a new way of searching altogether. Fact 18. The Kepler Revolution. When the Kepler Space Telescope launched, it carried a simple, elegant mission: stare at one patch of sky and watch for tiny dips in starlight. For years, it observed over 150,000 stars, waiting patiently for the soft, rhythmic shadows of passing planets. What followed was nothing short of a cosmic awakening. Kepler revealed thousands of possible worlds: small ones, large ones, warm ones, frozen ones, an entire menagerie hidden in plain sight. It reshaped our understanding of the galaxy, showing that planets are not rare jewels, but common companions to stars. Its quiet, unwavering watch turned the night sky into a tapestry of potential homes. And with Kepler's success, the search expanded to the rest of the sky. Fact 19. The TESS Sky Survey. After Kepler's dedicated gaze, a new mission rose to continue the search. TESS, the Transiting Exoplanet Survey Satellite. Instead of staring at just one region, TESS gently sweeps its eyes across nearly the entire sky, sector by sector, like a lantern slowly turning to illuminate every corner of a room. Its work is broad and patient, tracing the soft dips in brightness that hint at distant planets. TESS finds worlds around bright, nearby stars, planets close enough for future telescopes to study in fine detail. Some discoveries are small and rocky, others warm and gaseous, each one revealed by the slightest shadow. With every new sector observed, more possibilities unfold. And from this sweeping survey, the number of known worlds began to blossom. Fact 20. Thousands upon thousands. It didn't take long for the count to grow. What began with a single confirmed world has now grown into a vast catalog of thousands, with many more waiting to be verified. Each new discovery is like placing a star-shaped pin on a cosmic map and whispering, "Here too, a world exists." Most of these planets lie far beyond anything we could ever visit, yet they remind us that the galaxy is vibrant, full, and alive with variety. These thousands represent only a small fraction of what truly exists. For every world we find, many others remain hidden, too small to detect, too distant, or transiting at angles we cannot see. It is a gentle reminder that the universe is deeper than our instruments can reach. And within this incredible diversity, the first families of exoplanets began to take shape in our imagination. Fact 21. The heavyweights. Among the first worlds we learned to recognize were the giants, the massive planets made mostly of swirling gas and thick clouds. These heavyweights resemble Jupiter and Saturn, but many orbit far differently from our own gentle giants. Some sit close to their stars, warmed until their atmospheres glow softly. Others drift far out, cold and serene beneath faint starlight. Their layers blend into one another like painted watercolors. Hydrogen, helium, deeper pressures, deeper hues. Though we cannot see their surfaces, we imagine vast winds sweeping through their upper clouds, sculpting patterns that shift over centuries. And drifting nearby, a slightly smaller family of worlds begins to emerge from the cosmic dark. Fact 22. The warm Neptunes beyond the E. Gas giants lie the warm Neptunes, planets smaller than Jupiter, but larger than Earth, wrapped in soft layers of gas and vapor. These worlds often circle their stars at cozy distances, close enough to glow with gentle warmth, but far enough to avoid the fierce heat that scorches hot Jupiters. Their atmospheres may shimmer with clouds of water vapor, methane, or exotic ice crystals drifting in silent, swirling currents. Some warm Neptunes may even have rocky cores surrounded by deep oceans of superheated fluid, a strange blend of liquid and gas shaped by pressure. Though we can't see them directly, their shadows and spectral signatures paint a picture of calm, drifting giants. And just below them in size, another intriguing class of worlds comes into view. Fact 23. The super-Earths. Super-Earths are among the most common planets we've found, even though none exist in our own solar system. They are rocky and solid like Earth, but larger, sometimes twice its size, sometimes more. That extra mass gives them stronger gravity, which may help them hold on to thick atmospheres or vast oceans. Some could be warm and gentle, with soft breezes over stony landscapes. Others might be rugged worlds of towering mountains, deep valleys, or shimmering volcanic plains. Astronomers dream of the possibilities: glowing sunsets under dense skies, continents shaped by powerful tectonics, or blue waters stretching from horizon to horizon. These worlds feel familiar yet mysterious, offering a comforting thought that Earth-like conditions may be common. And among these rocky giants, a smaller, mistier kind of planet drifts quietly. Fact 24. The mini-Neptunes. Mini-Neptunes sit between rocky worlds and gas giants, wrapped in thick, gentle envelopes of gas over small, solid cores. They may have layers of vapor so deep that no surface ever appears, just a gradual transition from airy clouds to dense, pressurized interiors. Their atmospheres might be cool and calm, or warm and softly glowing, depending on their distance from their stars. Some scientists think mini-Neptunes could hide oceans beneath their clouds, warm enough to remain liquid even without direct sunlight. Others may simply be puffy worlds of gas, drifting peacefully in their orbits, neither harsh nor extreme, just quietly floating through the darkness. And farther in, where stars bathe their planets in fierce light, stranger giants await. Fact 25. The ultra-hot Jupiters. Some gas giants wander so close to their stars that they are warmed to extraordinary temperatures. These ultra-hot Jupiters complete an orbit in just a few days, circling their suns with breathtaking speed. Their day sides can glow like heated metal, reaching temperatures hotter than some small stars. In such intense light, molecules may break apart, only to drift back together on the cooler night side in a quiet chemical dance. Winds race across these worlds faster than sound, carrying heat from the scorched hemisphere to the dimmer one. Yet despite their extreme nature, they drift smoothly along their orbits, steady and unhurried. They remind us that even the most intense worlds can move through space with gentle grace. And beyond these blazing giants lie planets shaped by very different fires. Fact 26. Lava worlds. Some rocky planets orbit so close to their stars that their surfaces never truly cool. These are the lava worlds, places where oceans are made of molten rock, and mountains rise and fall like slow waves of glowing magma. The heat is constant, pressing down like a warm, endless day, with stars looming large in the sky and horizons shimmering with radiant haze. On the night side, if such a side exists at all, the lava may harden into dark, cracked plates before melting again at dawn. These worlds are dynamic, shifting landscapes shaped by ceaseless heat. Though they are inhospitable to life as we know it, their fiery surfaces hold a strange, hypnotic beauty. And farther out, in cooler orbits, some planets trade fire for water. Fact 27. Ocean worlds. Ocean worlds are planets entirely covered in water, vast, uninterrupted seas stretching from pole to pole. With no continents to break the waves, their surfaces may be calm and glassy, reflecting their starlight like a mirrored dream. Beneath these endless oceans, pressures increase gently but steadily, creating exotic forms of ice or warm layers of water heated by the planet's core. Some ocean worlds may have atmospheres rich with mist, sending soft clouds drifting across their horizons. Others might hide deep, warm currents where chemistry slowly stirs, offering peaceful conditions for life to emerge. These are worlds of fluid beauty, serene and softly swaying. And just a little farther from their suns, the seas begin to freeze into quiet, gleaming plains. Fact 28. Ice giants and twilight. Farther from their stars, some planets live in constant twilight, too cold for liquid water, too distant for bright, warming rays. These are the ice giants, with surfaces or atmospheres touched by frost and deep layers of frozen gases. Their skies may glow in muted blues or soft grays, illuminated only by faint starlight reflecting off their icy clouds. Winds drift slowly here, carrying particles of frozen mist across calm, wide horizons. Beneath their chilled atmospheres, deeper layers may still hold secrets. Warm, pressurized interiors, or hidden oceans locked beneath miles of ice. Though they appear quiet and still from afar, these cold worlds cradle complex structures and subtle beauty. And deeper still, under crushing pressures, stranger materials begin to form. Fact 29. Diamond worlds. Some planets form in environments rich with carbon and pressure, the perfect conditions for diamonds to grow not as gemstones, but as vast planetary layers. These diamond worlds may have surfaces made of hardened carbon, with interiors glittering in crystalline forms. Under immense heat and gravity, carbon can compress into diamond plains or deep sparkling layers that stretch for thousands of miles. Though we may never stand on such a world, imagining the glimmer of starlight reflecting off diamond cliffs or frozen carbon seas evokes a quiet sense of wonder. These places challenge our expectations, reminding us that other planets need not resemble Earth to be extraordinary. And just above these glittering depths, some worlds paint their skies with the strangest colors. Fact 30. Cloud tops of exotic hues. In distant atmospheres, chemistry becomes art. Certain planets brew clouds from minerals and metals, creating skies tinted with unusual hues: sapphire blues, copper reds, or pale amethyst purples. Winds swirl these colorful vapors into soft sweeping patterns, shading the horizon with tones we've never seen on Earth. Each atmosphere becomes a kind of cosmic watercolor, shaped by sunlight, heat, and the planet's unique ingredients. Some worlds may even host shimmering reflective clouds made of silicates, catching starlight like drifting shards of glass. Others might glow faintly from within, warmed by internal heat and tinted by exotic gases. These skies remind us that beauty in the cosmos is vast and varied, and beyond these atmospheric canvases, we begin to listen for the first hints of alien air. Fact 31. The first sniff of alien air. Detecting the atmosphere of a distant planet is a delicate art, almost like catching the faintest scent carried on a distant breeze. When a planet passes in front of its star, a tiny portion of starlight filters through its atmosphere before reaching us. That light carries a signature, a subtle pattern shaped by the gases it passed through. With sensitive instruments, we can study those patterns and discover what the air of another world is made of. The first time scientists detected an exoplanet atmosphere, it felt like opening a window to a faraway place. Sodium in the skies of a giant planet revealed itself in the soft dimming of specific wavelengths. It was a small clue, but a powerful one. Proof that alien atmospheres could speak to us across light years. And as we learned to read these signatures, new colors began to appear. Fact 32. The subtle colors of gas. Every gas absorbs light in a unique way, leaving behind slender, quiet gaps in the star's spectrum. These gaps form patterns, delicate fingerprints that tell us what elements drift in a planet's air. Hydrogen hums in gentle blues, methane dips into deeper reds, and water vapor leaves soft impressions that fade like breath on glass. Even when a planet is too far to see directly, its atmosphere can reveal itself in these subtle shades. By examining these spectral fingerprints, We can learn about temperatures, weather patterns, and even cloud layers. It's as though the planet is whispering its story through the starlight, telling us about winds, chemistry, and the soft shape of its sky. And among all these atmospheric tales, some speak of worlds wrapped in warming blankets of gas. Fact 33. The greenhouse worlds. Some planets are held in gentle warmth by thick atmospheres rich in greenhouse gases. These worlds trap heat the way a soft quilt keeps in warmth on a cool night. Depending on their composition, greenhouse atmospheres can create temperate surfaces on rocky planets or transform giants into warm, glowing spheres. Even at great distances from their stars, the trapped heat can keep oceans liquid or surfaces mild. On super-Earths and mini-Neptunes, greenhouse effects might create calm, hazy skies that glow softly under starlight. Layers of gas swirl slowly, distributing warmth across the globe. Though conditions vary widely, these planets remind us how profoundly an atmosphere can shape a world's destiny. And beyond these cozy spheres lie planets with skies far clearer and more open to the stars. Fact 34. The clear-skied wanderers. Not every planet is wrapped in thick clouds or swirling vapors. Some worlds possess atmospheres so thin or so transparent that starlight passes through them almost untouched. These clear-skied wanderers reveal their secrets more easily, allowing us to glimpse the shapes of their atmospheres through their spectral signatures. Their horizons may be crisp and open, with little haze to soften the edges of dawn or dusk. On such planets, sunsets could fade gently without cloud banks to catch the light. Stars might shine brighter through their skies, twinkling with a clarity we rarely see from Earth. Their simplicity makes them valuable to astronomers, offering clean, elegant clues about their composition and temperature. And beyond these open skies, stranger weather patterns begin to unfold. Fact 35. Rains of metal and glass. In some distant worlds, clouds are made not of water, but of vaporized minerals. And when they rain molten wonders. Iron droplets may fall like heavy, glowing beads. Silicate dust can condense into tiny shards of glass that drift sideways on powerful winds. On ultra-hot planets, titanium oxide may form hazy cloud layers, giving the sky a muted metallic gleam. These exotic rains follow the same gentle physics as water on Earth, but their ingredients turn every shower into a spectacle of strange chemistry. Even in such harsh environments, there is a quiet rhythm. Vapor rises, condenses, and falls again, repeating endlessly under the watch of an alien sun. And where some atmospheres push their heat skyward, others cradle softer conditions where life could quietly stir. Fact 36. The habitable zone. Around every star lies a gentle ring where temperatures could allow liquid water to exist, a band known as the habitable zone. It is neither too close nor too far, a calm middle place where warmth can linger without overwhelming heat. Planets drifting through this band may host oceans, moist air, or mild climates, depending on their size and composition. The habitable zone shifts with the brightness of its star. Around small red dwarfs, it hugs close, forming a warm, intimate circle. Around larger stars, it stretches wide like a broad, sunlit meadow. Not every world in this band is truly livable, but its presence offers hope, a quiet suggestion that comfort may bloom in the vastness of space. And just within this gentle region, some worlds begin to resemble home in surprising ways. Fact 37. Warm, Earth-like worlds. Some of the most hopeful planets we've found are those that resemble our own world in size, temperature, and gentle illumination. These warm Earth-like worlds drift in the comfortable glow of their stars, receiving just enough light to keep water liquid and breezes mild. Their surfaces may host continents, oceans, or broad plains of stone and soil. But from afar, we know only their subtle signals, tiny hints carried in starlight. Though we can't see these worlds directly, their transits reveal their size, and their wobbles reveal their mass. When the numbers align, we're left with a quiet possibility, a rocky planet with steady warmth, perhaps with clouds drifting lazily across a blue horizon. They offer a familiar kind of calm, even across light years. And in many of these systems, close orbits create worlds with extraordinary lighting. Fact 38. Tidally locked. Planets that orbit very near their stars often become tidally locked. One side forever facing the light, the other steeped in endless night. The day side may glow with perpetual warmth, its skies painted in steady brilliance. The night side rests in deep shadow, glowing only with faint starlight reflected from distant nebulae, or the quiet heat rising from within. Between these extremes lies the terminator zone, a ring of soft twilight encircling the planet. Here, sunlight grazes the horizon without ever fully rising or setting. The air might be gentle, the temperature steady, and any winds calm as they move between night and day. This perpetual twilight could create conditions surprisingly favorable for life, wrapped in eternal dusk. And it is this gentle boundary that holds one of the universe's most peaceful possibilities. Fact 39. The Twilight Ring. On a tidally locked world, the twilight ring forms a serene, circular world where day and night meet in harmony. In this quiet zone, golden light might glow softly along the horizon, casting long, gentle shadows over the landscape. Temperatures here may settle into a comfortable balance, warm enough for liquid water, cool enough for stability. Winds drift from the hot side to the cold, smoothing out extremes until the air becomes calm. If life were to find a foothold on such a planet, it might flourish in this delicate ring, sheltered from scorching heat and bitter cold. Plants or simple organisms could cling to the ribbon of twilight, living in a world where dawn never changes. And just beyond this peaceful belt, the fragility of worlds becomes clear. Fact 40. The fragility of atmospheres. A planet's atmosphere is a delicate thing. A thin, protective veil balancing gravity, temperature, and the quiet breath of its star. But around some suns, especially the more active ones, powerful stellar winds can sweep across nearby planets with enough force to erode their air. Over millions of years, a world that once held soft skies and warm breezes may find its atmosphere thinning, leaving it bare and exposed. This fragility reminds us how precious a stable atmosphere truly is. Without it, oceans vanish, temperatures swing wildly, and surface conditions become harsh and unforgiving. Even so, some planets manage to hold on, sheltered by magnetic fields or sheer distance from their turbulent stars. And in rare, harmonious systems, entire families of planets thrive together in delicate balance. Fact 41. The TRAPPIST-1 family. One of the most intriguing planetary systems we've ever found orbits a small, cool red dwarf called TRAPPIST-1. Around this quiet star circle, 7 Earth-sized planets, packed closely together like beads on a gentle thread. Their orbits form a graceful pattern, each world tugging softly on the next, moving with a rhythm that keeps the entire system stable. Some of these planets lie in the star's habitable zone, where temperatures could allow liquid water. Others are colder or warmer, yet each one adds to the beauty of this compact family. Starsets and sunrises would happen quickly here, with the neighboring planets appearing as bright crescents in the sky, drifting silently like lanterns. And holding all 7 worlds in place is a delicate celestial choreography. Fact 42. The dance of resonance. The TRAPPIST-1 planets follow a special orbital rhythm known as resonance. This means their orbits are linked in perfect mathematical harmony. When one planet completes a certain number of loops, its neighbors complete theirs in matching proportions. This resonance keeps the system stable, preventing chaotic shifts that might otherwise send worlds drifting out of place. It's as if the planets are following a cosmic waltz, each step timed to the others, each orbit reinforcing the calm. Through this gentle balance, the worlds maintain their spacing, their temperatures, and their long-term stability. Resonance becomes their quiet guide, shaping their destinies over billions of years. And just beyond this rhythmic family, another nearby world drifts in hopeful possibility. Fact 43. LHS 1140b and its quiet seas. Not far from us in cosmic terms, a planet called LHS 1140b circles a cool red dwarf star with a slow and steady rhythm. Larger than Earth and comfortably placed within its star's habitable zone, this super-Earth is one of the most promising worlds we know. Its density suggests a rocky body, and its gentle distance from its star hints at the possibility of liquid water, perhaps even wide, temperate seas. Because the star is dim and calm, the planet receives a soft, steady glow rather than harsh radiation. If oceans exist there, they might lie beneath a mild sky, stirred only by slow tides and gentle winds. The world feels like a quiet companion, a nearby reminder that calm, Earth-like places may be scattered throughout the galaxy. And just a little closer to home, an even more famous neighbor draws our attention. Fact 44. Proxima b, our nearest neighbor. Proxima b orbits Proxima Centauri, the closest star to our Sun, only a little over 4 light-years away. This small planet lies within its star's habitable zone and is roughly Earth-sized, making it one of the most intriguing candidates for future study. It circles its cool red dwarf quickly, completing a full orbit in just 11 days, held close by the star's gentle warmth. Though Proxima Centauri can produce flares, the planet may possess a strong magnetic field or thick atmosphere to soften their effects. If conditions permit, Proxima b could host calm regions where temperatures settle into comfortable ranges and light falls in soft red hues. It is the first world outside our solar system that future probes might someday visit. And just beyond it, another ancient star cradles a quiet companion of its own. Fact 45. Barnard's Star's Companions. Barnard's star is one of the oldest and fastest moving stars in our stellar neighborhood, drifting across the sky with slow determination. For decades, astronomers have searched for planets around it, listening for the subtle wobble that would reveal a hidden world. One promising candidate, Barnard's star B, appears to be a frozen super-Earth orbiting just outside the habitable zone. Though likely cold and dimly lit, such a world may still hold layers of complexity beneath its icy exterior. Perhaps subsurface oceans warmed by the planet's interior heat, or quiet plains frozen under starlight. Barnard's star B reminds us that even the most ancient stars may shelter planets, each carrying its own quiet history. And far beyond these nearby systems, more giants wait with storms and mysteries of their own. Fact at 46. 51. Pegasi b, the first hot Jupiter. Among the early discoveries that reshaped our understanding of planetary systems was 51 Pegasi b, the first exoplanet found orbiting a sun-like star. This world was a revelation, a giant planet sitting impossibly close to its star, completing an orbit in just over 4 days. Its existence upended our expectations, proving that planetary families could be far stranger and more varied than our own. 51. Pegasi b glows with intense stellar warmth, its atmosphere stirred by powerful winds and shimmering heat. Though we will never stand on its surface, it has none. The planet's silent revolution around its star opened the floodgates of exoplanet discovery. It reminded us that the universe holds countless surprises. And as we learned more, we realized that some giants do not stay where they are born. Fact 47. Strange migrating giants. Hot Jupiters, like 51 Pegasi b, likely did not form near their scorching stars. Instead, they may have been born far from the heat, in the cool outskirts of their systems, before drifting inward over millions of years. This slow migration shapes everything around them, clearing paths through dust, shifting smaller planets aside, and sometimes preventing new worlds from forming at all. The process is gentle but transformative, like a giant quietly rearranging a room as it moves through. These migrating giants teach us that planetary systems are dynamic, evolving structures, not fixed arrangements. Their wandering paths help explain why so many distant solar systems look nothing like our own, and some giants change not only their orbits, but their very shapes. Fact 48. Puffed up planets. Some gas giants expand under the constant heat of their stars, becoming puffed up worlds, with atmospheres swollen to extraordinary sizes. Though their masses may be similar to Jupiter's, their diameters can stretch far wider, their outer layers heated until they billow like soft, glowing balloons. Their atmospheres are thin and extended, drifting outward in vast, delicate envelopes. These planets appear large in transit data, their shadows deeper and more noticeable as they pass in front of their stars. Inside, they may be surprisingly light and airy, with gentle gradients of gas leading down toward their denser cores. Puffed-up planets remind us that warmth can shape worlds in quiet, unexpected ways. And not far from these swollen giants, some planets follow paths that defy all ordinary expectations. Fact 49. Planets with tilted orbits. Most planets orbit neatly around the equators of their stars, following the gentle plane laid down during their formation. But some worlds tilt their paths dramatically, circling at strange angles, even looping backward against the star's rotation. These misaligned orbits reveal ancient turbulence. Perhaps a passing star tugged the system, or a giant planet migrated inward and disrupted the harmony. From afar, these tilted worlds move in graceful, unusual arcs, rising high above their star's equator before sweeping back down again. Their seasons, if they have them, might be unpredictable, shaped by dramatic changes in sunlight. Yet they continue on their angled paths with quiet steadiness. And while some tilt their orbits, others express their nature through extraordinary storms. Fact 50. Storms larger than continents. On distant gas giants, storms can grow to astonishing sizes, far larger than anything Earth has ever known. Vast tempests circle around the planet's belts, glowing faintly in thermal light, their winds stretching thousands of miles across. Some storms may last for centuries, swirling endlessly in the deep, layered atmospheres of these colossal worlds. Clouds of exotic chemicals swirl in slow spirals, painting patterns Across the sky, like soft, drifting brushstrokes, lightning may flicker within the hidden depths, illuminating towering columns of cloud. Even in their violence, these storms move with a kind of cosmic grace, immense, powerful, yet calm when viewed from the safety of light years away. And from these swirling giants, we shift to the delicate architecture of entire planetary families. Fact 51. Compact planetary systems. Some stars host tightly packed systems where many planets orbit astonishingly close to one another. These worlds can complete their orbits in days, forming elegant chains of motion that remain stable over billions of years. In these compact families, planets might appear enormous in each other's skies, crescents or full-faced spheres drifting slowly above the horizon. Despite their closeness, these worlds can remain peaceful, held in balanced rhythms that prevent collisions or chaos. Their gravitational dances create predictable patterns, like soft clockwork ticking beneath starlight. Astronomers treasure these systems for the clarity they offer. With so many planets aligned and transiting, they become natural laboratories of cosmic harmony. And just beyond these tight-knit systems lie families spread across far wider cosmic planes. Fact 52. Wide-ranging families. Not all planetary systems are compact or closely knit. Some worlds wander far from their stars, tracing long, sweeping orbits that stretch into the quiet outskirts of their systems. These distant planets may take decades or even centuries to complete a single year, drifting through regions where starlight falls like a soft, diluted glow. Their skies may be dim, painted in pale hues as the star appears only as a bright point, more like a lantern than a sun. Despite their vast distances, these planets remain loyal to their stars, held gently in place by gravity's steady pull. Their orbits form the outer borders of their systems, like wide, silent gardens beyond the warm inner realms. And in these gentle outskirts, the rules of planetary alignment sometimes shift in unexpected ways. And as we move outward, we find places where the very structure of a system becomes quietly unusual. Fact 53. Misaligned disks. Some planetary systems begin their lives in tilted or twisted protoplanetary disks. Great, swirling sheets of dust that don't line up neatly with their star's rotation. This misalignment may come from nearby stars tugging on the forming system, or from the lingering tilt of the cloud that birthed it. Whatever the cause, planets born in these tilted disks continue to follow angled paths long after the disk has faded. From afar, their orbits look like gentle curves, rising above and dipping below the system's main plane, creating a graceful, three-dimensional ballet. Though tilted, these worlds remain stable, circling their stars in soft, looping motions. The cosmos allows for many shapes, and even misaligned beginnings can blossom into long-lived planetary families. And in the darkest corners of the galaxy, some planets orbit stars very different from our Sun. Fact 54. Planets around pulsars. A pulsar is the dense, rapidly spinning core left behind after a massive star collapses, an object no larger than a city, yet heavier than the Sun. Its beams of radiation sweep across space like cosmic lighthouses, flashing with astonishing regularity. Around such extreme stars, it seems unlikely for planets to survive. And yet, some do. In these quiet rhythmic pulses, astronomers have detected tiny gravitational tugs revealing small, stable worlds. These planets endure conditions unlike anything in our solar system. Intense radiation, deep darkness, and a star that sings in radio waves rather than glowing with warm light. Yet they orbit steadily, calm in their own unusual way. Their existence proves that planets can arise or survive, even in the aftermath of stellar catastrophe. And beyond these dense, rhythmic stars lie the dusty outer edges that frame entire planetary systems. Fact 55. Debris, belts, and outer edges. At the far reaches of many planetary systems lie broad belts of dust, ice, and rocky fragments, the quiet leftovers of planet formation. These debris belts are like cosmic shorelines, marking the outer boundaries where planets give way to drifting particles. Bathed in faint starlight, their grains shine softly, scattering light like distant, icy sand. In some systems, the belts form elegant rings. In others, they stretch into wide, diffuse clouds. These regions may host countless small bodies, frozen comets, crumbly asteroids, and pieces that never grew into worlds. Over millions of years, collisions among these fragments send shimmering clouds of dust outward, tracing delicate arcs through the dark. Debris belts remind us that even unfinished parts of a system hold a serene, quiet beauty. And closer to the star, within the warmer realms, some planets experience a far more dramatic fate. Fact 56. Evaporating worlds. Some planets orbit so close to their stars that their atmospheres begin to escape into space, dissolving slowly into long, ghostly tails. These evaporating worlds are heated until their gases expand and drift away, forming soft, mist-like streams that follow them along their orbits. From afar, they resemble comets, glowing gently as starlight filters through the escaping vapor. Though this loss is gradual, it changes the planet over time. A once thick atmosphere may thin into a fragile shell. A small world may shrink as its layers drift off into the void. Yet even as they lose their air, these planets continue to move with steady grace, their fading envelopes trailing behind them like quiet, luminous veils. And as some worlds shed their atmospheres, others cast shadows that reveal their presence with elegant precision. Fact 57. Planets that eclipse their stars. When a planet passes directly in front of its star, it creates a tiny eclipse, a momentary dimming that ripples gently through the starlight. Even though the planet itself is far too small to see, this soft dip can tell us its size, shape, and orbit. For a brief moment, the star's brightness changes in a way that speaks clearly across light years. Some planets create deep, well-defined shadows. Others cause only the faintest flicker. But each transit becomes a quiet signature, a rhythmic reminder that a world is there, circling faithfully in its path. These eclipses form the heartbeat of exoplanet discovery, steady and reliable. And in some rare cases, the worlds that cast these shadows carry rings as breathtaking as Saturn's, or even larger. Fact 58. Planets with rings. Some exoplanets may carry rings far grander than any in our solar system. Vast halos of ice, dust, and rock that encircle them in sweeping, luminous arcs. These rings can stretch millions of miles, forming graceful, shimmering structures that reflect starlight like drifting curtains of frost. From a nearby moon or neighboring planet, such rings would dominate the sky, glowing softly as they catch the faint light of their distant sun. In a few systems, observations hint at rings so large they could rival the diameter of entire planets. Their shadows, cast during transit, reveal delicate dips and curves in the starlight, whispering of intricate shapes unseen by human eyes. These ringed giants move with quiet majesty through their orbits. And where rings exist, moons often follow. Fact 59. Planets with moons, yet unknown. Though we have found thousands of exoplanets, The moons that may circle them remain hidden in deeper shadows. Exomoons are harder to detect. Their signals faint, their orbits subtle, their effects often masked by their larger parent worlds. Yet many likely exist. Small, rocky companions, icy spheres, or captured wanderers drifting in dance around their planets. If we could see these moons, we might find landscapes as diverse as the worlds in our own system. Smooth frozen plains, volcanic ridges, or quiet lakes beneath thin atmospheres. Some might even offer conditions gentle enough for life. For now, their presence is felt only in hints and tremors, soft tugs in the data. And just as some planets lose nothing to the void, others trail delicate tails like silent comets. Fact 60. Planets with comet-like tails. A few unusual planets shed material so steadily that they leave long, glowing tails behind them, flowing streams of gas or dust that stretch far into space. These tails form when intense starlight heats the planet's outer layers, or when radiation pressure sweeps particles away. What remains is a faint, graceful plume that curves gently as the planet moves along its orbit. From a distance, these worlds resemble drifting embers or slow-moving comets. Their tails reveal changing seasons, shifting temperatures, and the fragile balance of their atmospheres. Even as they lose material, they continue their steady motion around their stars, carrying their bright, delicate trails wherever they go. And from these drifting signatures, we turn toward the tools that allow us to detect such distant wonders at all. Fact 61. Measuring starlight. Every exoplanet discovery begins with something simple: counting photons, one by one, as they arrive from a distant star. Telescopes collect this gentle rain of light, breaking it into patterns that reveal a star's brightness, its colors, and its subtle changes over time. Even the faintest shift, a tiny dip, a slight wobble, a soft variation in hue, can whisper the presence of a hidden planet. This work requires patience and stillness. Instruments watch a single star for weeks, months, or even years, listening carefully to its steady glow. Each point of data is like a heartbeat, and within those rhythms, astronomers search for a planet's soft footsteps. It is a calm, methodical art, the science of reading light. And sometimes, the universe helps by bending that light in extraordinary ways. Fact 62. Microlensing's brief spark. When a massive object passes between us and a distant star, its gravity gently bends the starlight, temporarily magnifying the star's brightness. This rare alignment, called gravitational microlensing, acts like a natural cosmic lens. If a planet orbits the foreground star, its own small gravitational tug adds a tiny extra flicker to the brightening curve. These events are fleeting, lasting days or weeks, and they never repeat in quite the same way. Yet in that brief spark of magnified light, a hidden world can be revealed, a giant far from its sun, a small rocky planet, or even a cold world in the outer reaches of a distant system. Microlensing allows us to glimpse planets we might never detect by any other means. And for a few lucky systems, we can see something even more extraordinary: the planets themselves. Fact 63. Direct imaging. Most exoplanets are far too dim to see directly, overwhelmed by the brilliance of their stars. But with advanced instruments and clever techniques, astronomers have begun to capture faint, shimmering images of worlds orbiting far from their suns. These planets appear as tiny points of light, glowing softly in infrared wavelengths, their heat gently radiating into the darkness. Directly imaged planets are often young, still warm from formation. Their broad orbits give us enough space to block out their starlight and glimpse their lonely glow. Seeing a planet directly, not as a dip or a wobble, but as a silent ember drifting beside its star, reminds us how vast and beautiful the cosmos can be. And to measure the tiniest motions of these stars, another technique steps forward with delicate precision. Fact 64. Astrometry's tiny motions. Astrometry is the art of measuring a star's position with exquisite precision, watching for the tiniest shift in its place in the sky. If a planet orbits the star does not remain perfectly still. It traces a small, gentle loop as the planet tugs on it. These motions are incredibly subtle, often no wider than the width of a coin seen from thousands of miles away. Yet with careful observation and patience, astronomers can detect these soft curves. Each loop reveals the presence of a planet, along with its mass and the shape of its orbit. Astrometry is a quiet technique, relying on stability and time rather than brightness or color. It listens to the star's slow dance, capturing motions too delicate for the eye. And as our tools improve, the future of exoplanet discovery grows even clearer. Fact 65. Future telescopes. In the years ahead, new telescopes will rise into space like patient guardians of the night. Some will unfold giant mirrors capable of gathering more light than any instrument before them. Others will fly in formation, using multiple spacecraft to create a single, vast observing system. With these new eyes, we will be able to study smaller planets, fainter atmospheres, and worlds far more distant than we can see today. These telescopes will read starlight with gentle precision, detecting molecules, clouds, and perhaps even signs of habitability. They will give us sharper spectra, finer images, and deeper insights into the quiet worlds that drift beside distant suns. The universe is preparing to reveal more of itself. And among the clues these instruments search for, water remains one of the most meaningful. Fact 66. Water vapor signatures. Water is one of the most precious indicators of a potentially life-friendly world. When starlight passes through a planet's atmosphere, water vapor leaves a distinctive imprint, a soft dip in certain wavelengths that stands out like a tiny wave in a calm sea. Detecting this signature can mean that clouds, humidity, or even vapor-rich air surround the planet. Water vapor has been found in the skies of distant giants, warm Neptunes, and a few small planets as well. While its presence doesn't guarantee oceans below, it whispers of familiar chemistry, of temperatures where water can rise into air and fall again as gentle rain. In the silence of space, this is one of the most hopeful clues we can hear. And where water leaves its mark, many other exotic molecules also drift through alien skies. Fact 67. Exotic molecules. In the atmospheres of distant planets, chemistry becomes a quiet form of art. Some worlds hold clouds of methane swirling through cool skies, while others warm themselves beneath blankets of ammonia. On ultra-hot planets, stranger ingredients appear. Titanium oxide drifting like metallic mist, vanadium compounds tinting the air, or silicate vapors rising from superheated surfaces. These exotic molecules absorb and reflect starlight in delicate, distinctive patterns, allowing us to recognize them even from light years away. Each chemical leaves its soft fingerprint, revealing temperatures, pressures, and hidden layers of cloud. Though we may never breathe the air of these worlds, their molecular signatures paint vivid impressions, offering distant glimpses of landscapes unlike any on Earth. And among these chemicals lies one of the most meaningful clues, something that may whisper of life. Fact 68. The search for oxygen. Oxygen, on Earth, is a quiet signature of life. It fills our skies because countless living organisms continually renew it. Elsewhere in the universe, oxygen might appear through natural processes, perhaps from sunlight breaking apart water vapor, or from minerals releasing gas into the air. But its presence, especially alongside other certain molecules, sparks careful curiosity. Scientists study distant atmospheres for the gentle dips in light that oxygen creates, hoping to find the right combination of gases. Oxygen balanced with methane, or ozone paired with water vapor. These mixtures could suggest biological activity, subtle but steady. Detecting such patterns would be like hearing a soft echo across space. Not a shout, but a hint that something might be breathing beneath an alien sky. And wherever carbon drifts in the cosmos, another hopeful sign begins to take shape. Fact 69. Traces of carbon and life. Carbon is a universal storyteller, the backbone of organic chemistry and a major player in planetary atmospheres. When starlight filters through a distant world sky, carbon-based molecules leave graceful signatures behind. Methane, carbon dioxide, carbon monoxide. Each one tells a different tale about the planet's climate, temperature, and possible processes happening on its surface or deep within. The presence of certain carbon molecules together, especially those that coexist uneasily, like methane and oxygen, could hint at something unusual, perhaps even biological. Though such clues are faint and ambiguous, they form the first threads of a larger narrative. Like footprints in soft dust, they don't prove life, but they lead us gently in its direction. And through these spectral hints, we soon arrive at one of the most beautiful aspects of distant worlds, the colors of their skies. Fact 70. The colors of distant skies. Every planet paints its sky with the colors of its atmosphere. On some worlds, tiny particles scatter blue light, creating skies as soft and pale as a quiet morning on Earth. On others, thicker hazes may turn the heavens amber, rose gold, or even deep violet. Exotic gases can tint the air in unexpected ways. Copper clouds creating muted reds, methane mists softening everything into tranquil shades of turquoise. Because we cannot see these skies directly, we read their colors through the fingerprints they leave in starlight. A hint of blue may suggest a clear atmosphere. A steep slope toward red may reveal thick hazes or distant storms. Every hue becomes a whisper from the planet itself, painting silent pictures across light years. And these pictures change dramatically when planets follow unusual or extreme paths around their stars. Fact 71. Yearless planets. Some planets circle their stars so swiftly that their entire year lasts only a handful of hours. They race around their suns like silent runners, completing full orbits before a day could pass on Earth. These tight, rapid loops keep the planets locked in unending cycles of light and warmth, their skies experiencing constant sunrise or sunset as they race along their paths. Such worlds are often scorched, their surfaces heated by relentless starlight. Yet despite the intensity, their orbits remain smooth and steady, held firmly by gravity's quiet pull. A single orbit may be brief, but the rhythm endures, a heartbeat measured in hours, repeating endlessly in the cosmic night. And as we move outward from these close-in runners, we find planets whose years stretch into the far reaches of time. Fact 72. Decade-long seasons. Farther from their stars, live worlds with orbits so wide that their seasons last for decades. On these distant giants and cold super-Earths, winter may linger for years, casting the surface into deep, calm chill. Summer arrives slowly, warming the planet over long stretches of time, its gentle light spreading across landscapes that have waited patiently for the sun to return. Such planets move at a serene pace, drifting through space with quiet dignity. Their skies shift color gradually, their weather patterns unfolding in slow, deliberate rhythms. Life, if it exists, would have to adapt to patience, growing and resting in harmony with these long, steady cycles. And beyond these long year travelers lie planets that take even stranger, more elongated journeys around their suns. Fact 73. Highly eccentric paths. Some planets follow elongated, oval-shaped orbits known as highly eccentric paths. Instead of drifting in gentle circles, they sweep close to their stars in one part of their journey and then swing far out into the cold darkness in another. When they approach their suns, their skies brighten dramatically, warming their atmospheres and stirring winds that race across the surface. As they retreat, everything cools and quiets, settling into calm twilight. These dramatic cycles can shape a planet's climate in surprising ways. Sudden thaws, long frosts, or brief, warm glimmers that come only once every orbit. Yet despite the shifting extremes, the planets remain faithful to their looping paths, returning again and again in quiet cosmic rhythm. And at the far ends of these orbits, some planets circle stars that are nearing the ends of their own lives. Fact 74. Planets around dying stars. Even as stars age and transform, some planets remain in gentle orbit around them. White dwarfs, the dense, cooling remnants of sun-like stars, may host small rocky worlds that survive the tumultuous transition. These planets circle tiny, dim stars that glow like warm embers, providing soft, steady light. In such systems, the habitable zone lies close in, creating a delicate ring where temperatures might allow liquid water. If a planet happened to settle there, it could bask in a faint glow, warmed by a star that no longer burns fiercely but still whispers light into the dark. These worlds represent endurance, quiet survivors that drift peacefully through the long twilight of their suns. And strangely, even after a star dies, new worlds can sometimes form anew. Fact 75. Reborn planetary systems. After a massive star collapses, or a smaller one sheds its outer layers, the leftover material can gather into disks of dust and gas, the same kind of cradle that forms planets around young stars. In these disks, new worlds may emerge from the ashes of the old, shaped by the gravitational sway of the remnant star at their center. These planets, born around stellar remnants, are like phoenixes of the cosmos, rising quietly from material once scattered by a star's dying breath. Though their environments are unusual and often harsh, they demonstrate nature's resilience. Even in endings, the universe finds ways to begin again. And from these reborn systems, we drift toward the worlds that might resemble our own future discoveries. Fact 76. Earth twins. Yet to be found. Among all the worlds we've discovered, we have yet to find a true Earth twin. A planet with the same size, atmosphere, oceans, and gentle distance from its star. But the universe is vast, and astronomers believe that such planets almost certainly exist. Somewhere, there may be a world with blue horizons, drifting clouds, and continents warmed by familiar sunlight. We simply haven't looked long enough or deeply enough to find it yet. These potential Earth twins inspire much of our search. Each new telescope, each new survey, is a quiet step toward discovering a place that mirrors our own. When we finally find one, it will be like glimpsing a reflection of home across light years. Soft, distant, and full of possibility. And just beyond these imagined Earths, gentler ocean worlds await. Fact 77. Planets with soft blue oceans. Some exoplanets may be covered in soothing global oceans, vast unbroken surfaces reflecting their starlight in shimmering shades of blue. These seas could be calm and glass-like in low winds, or gently rolling under soft alien skies. Without continents to break the waves, storms may travel around the planet in long, graceful spirals, spreading warm rain across entire hemispheres. Beneath the surface, currents could flow slowly, warmed by the planet's core and enriched with minerals from deep hydrothermal vents. Life, if it exists there, might drift in the water like tiny, luminous lanterns. These ocean worlds offer a dreamlike vision. Planets where the entire surface breathes with the steady rhythm of tides. And some worlds, though similar in size and structure, may hold air so light and delicate it drifts like a whisper. Fact 78. Planets with quiet thin air. Not all atmospheres are dense and cloud-filled. Some planets possess thin, gentle envelopes of gas, atmospheres so light that they barely blur the stars during sunset. On these worlds, the sky might appear darker, the stars sharper, and the air cooler and still. Even small breezes would move softly across the surface, carrying dust or frost in delicate patterns. Thin atmospheres reveal the planet's surface more clearly to the cosmos, allowing starlight to reflect off oceans, rocks, or ice with little distortion. They may form when the planet is too small to hold heavy gases, or when stellar winds gradually strip the air away over millions of years. Yet even in their simplicity, these atmospheres create quiet, serene environments. And farther out still, worlds exist where the soil glows warm in hues of red and copper. Fact 79. Planets with rust-red soil. Some rocky worlds may be coated in iron-rich dust, their surfaces glowing in warm hues of rust-red and copper gold. Under the gentle light of their stars, these landscapes might resemble soft desert plains, stretching into hazy horizons where wind-blown particles drift like fine crimson powder. With thin atmospheres or mild weather, these planets could feel quiet and still, shaped more by time than by storms. Iron minerals react with air and moisture to create these earthy tones, painting entire worlds in shades reminiscent of Mars, but with their own character and light. From orbit, such planets might shine with a serene reddish glow, calm, muted, and ancient in appearance. And beneath some of these dusty shells, hidden waters may lie in silence. Fact 80. Planets with hidden subsurface. Seas beneath layers of ice or thick crust, some distant worlds may conceal vast subsurface oceans. These hidden seas could stretch for thousands of miles, warmed by geothermal heat rising from the planet's core. Encased beneath protective shells, they remain shielded from the harshness of space, creating stable, quiet environments where liquid water persists, even far from starlight. Such oceans might be completely dark, illuminated only by faint chemical reactions or the slow warmth from the rocky seafloor. Life, if present, could evolve in gentle isolation, drifting in still waters untouched by surface storms. Subsurface seas remind us that habitability can hide in unexpected places, not in sunlight, but in the quiet glow of a planet's inner warmth. And beyond these sheltered waters exist worlds that drift freely, guided by no star at all. Fact 81. Rogue planets. Rogue planets wander through the galaxy unbound, traveling without the guidance of a sun. They drift in endless night, illuminated only by distant starlight or the soft warmth left over from their formation. Some may hold thick atmospheres that trap heat, creating dim, gentle environments despite the cold of interstellar space. Others may be icy, spheres, coated in frost as they glide silently among the stars. Though these worlds lack the steady rhythm of day and night, they remain full-fledged planets, with mountains, valleys, oceans, or clouds shaped by their own internal processes. Their solitude has a quiet elegance. They remind us that not every world needs a sun to exist. Some are content to drift through the cosmic dark, calm and unhurried. And deeper into the galaxy, other planets find themselves captured or exchanged in gentle gravitational encounters. Fact 82. Captured giants. Occasionally, a wandering planet drifts close enough to a star system to be gently caught by its gravity. These captured giants arrive as visitors from the dark between the stars, settling into new orbits around unfamiliar suns. Their paths may be tilted, elongated, or oddly shaped, soft clues that they were not born where they now reside. Over time, these planets adapt to their new homes, warmed by starlight they once glided past as strangers. Captured worlds can be massive, with deep atmospheres and swirling winds shaped by their newfound stars. Their presence hints at ancient encounters, slow gravitational dances between passing systems, quiet exchanges written in the motions of drifting planets. These giants carry stories from elsewhere, tucked into their orbits like soft echoes of distant places. And in regions where stars are born in close company, even stranger origins unfold. Fact 83. Planets born in crowded clusters. Many stars begin their lives in clusters, groups packed with thousands of siblings glowing close together in quiet nebulae. In these busy nurseries, planets form amid gentle yet frequent gravitational nudges from neighboring stars. A young world may feel these tugs as tiny shifts in its path, shaping its orbit into something unique and slightly asymmetric. Despite the crowded environment, these worlds can still form stable, lasting systems. Their skies, however, might look very different from ours. Instead of a single sun dominating the horizon, they may see dozens or even hundreds of bright stars scattered across the night, shimmering through dusty cosmic clouds. These cluster-born planets remind us that not every world forms in solitude. Some arise amid the warm company of many suns, and even their earliest materials can differ depending on how rich or sparse their stellar neighborhood is in heavy elements. Fact 84. Metal-poor worlds. In the earliest days of the universe, stars were born from pristine clouds made mostly of hydrogen and helium. With few heavier elements available, the planets that formed around these ancient stars would have been simpler and more austere, built largely from light materials, lacking the rocky diversity we see on Earth. These metal-poor worlds may be dominated by vast seas of hydrogen or thick envelopes of gas, their cores small and plain. Even today, some stars in the Milky Way remain low in heavy elements, giving rise to planets with sparse, minimalist compositions. Though they may not host towering mountains or rich mineral plains, these worlds possess their own quiet charm, gentle spheres shaped by the earliest ingredients of the cosmos. And from these sparse beginnings, some planets grow rich in metals, forming heavier, denser realms of stone and iron. Fact 85. Metal-rich worlds. Some planets form in regions rich with heavy elements, places where previous generations of stars have lived, died, and scattered their enriched material into space. These metal-rich worlds tend to be dense and heavy, with thick rocky crusts and iron-rich cores. Their surfaces might be dark and mineral-like, dotted with metallic ores that shimmer faintly under alien sunlight. Mountain ranges could rise sharply, carved from stone infused with elements rare on Earth. Such planets may also hold complex chemistry in their atmospheres and soils, shaped by the abundance of heavy materials available during their formation. Their compositions tell a quiet story of cosmic recycling, the ashes of ancient stars becoming the building blocks of new worlds. In this way, metal-rich planets reflect the layered history of our galaxy. And as we zoom out from individual worlds, we find ourselves imagining just how many such planets truly exist. Fact 86. How many worlds exist? With every new discovery, our estimates grow. Today, astronomers believe the Milky Way may hold more than 1 trillion planets, perhaps several trillion. Nearly every star likely has at least one world, and many have entire families. Rocky spheres, icy giants, warm Earths, gas-shrouded titans. Between the stars, countless rogue planets drift freely, adding to the tally. This abundance is humbling to imagine. For every point of light in the night sky, there may be worlds circling quietly, warmed by their suns, sculpted by gravity, and shaped by time. The sheer number of these planets turns the universe into a vast ocean of possibility. Somewhere among them, life may bloom softly, unseen and undisturbed. And these worlds appear not only in galaxies like our own, but across many shapes of galaxies throughout the cosmos. Fact 87. Galactic shapes and their planets. Planets arise in every kind of galaxy. Spirals like the Milky Way, sprawling ellipticals, and small scattered dwarfs. In grand spiral arms, stars form in sweeping waves, creating planets in long, elegant arcs. Elliptical galaxies, though older and calmer, still cradle worlds formed from rich, mature materials. Even tiny dwarf galaxies, with their gentle smatterings of stars, host planets in quiet, isolated neighborhoods. The architecture of a galaxy shapes the environments where planets emerge. Dense clusters, lonely outskirts, or swirling arms lit by newborn stars. Yet across all these structures, the recipe remains the same. Dust, gas, gravity, and time. No matter the galaxy's shape, planets form wherever starlight is born. And some of the most mysterious planets lie in the hidden corners of our own Milky Way, where starlight barely reaches. Fact 88. The Milky Way's hidden corners. Our galaxy stretches far beyond what we can see. A grand spiral of stars with dim, quiet regions tucked between its glowing arms. In these hidden corners, starlight is faint, filtered through drifting clouds of dust that soften every beam. Yet even here, in places where stars appear as only gentle glimmers, planets form and evolve. These worlds receive only the softest touch of their suns, living in a calm that feels almost timeless. Some may orbit ancient stars billions of years old, their surfaces shaped by long, slow histories. Others may circle faint red dwarfs, glowing softly like embers in a wide, dusky room. These obscure worlds remind us that the galaxy is full of secrets, planets silently circling in places our telescopes can barely reach. And as the galaxy drifts through space, all these worlds move with it in a quiet cosmic journey. Fact 89. The motion of the galaxy. The Milky Way itself is not still. It glides through space at incredible speeds, carrying its stars and planets along with it like passengers on a serene, celestial voyage. Our solar system and every exoplanet system we've discovered moves together as part of this sweeping galactic current. Though we cannot feel it, everything around us is drifting, orbiting the galactic center in a vast 230 million year circuit. For any planet, its journey is twofold. It circles its star in calm, steady loops, while also traveling through the galaxy at immense speed. Yet from the surface of those worlds, the sky feels peaceful. Suns rise and set, moons drift overhead, and the greater motion remains silent. This layered movement adds depth to the story of every planet. And far beyond the edges of our reach lies the boundary of what we can know. Fact 90. The edge of what we can know. In the study of exoplanets, we face a gentle frontier, a place where light becomes too faint, signals too small, and distances too vast for our instruments to follow. Beyond this edge, countless worlds remain hidden, circling their stars in perfect anonymity. We know they exist, but they lie just beyond our sight, wrapped in darkness and time. This boundary isn't a wall, but a horizon, slowly expanding as our technology grows more sensitive and our patience deepens. Every new telescope pushes it a little farther, revealing planets once lost in the quiet. The edge of our knowledge is always moving, always softening, and as we continue to explore, we turn toward the human story, the patient work of cataloging and understanding these worlds. Fact 91. The first planet catalogs. As the discoveries began to grow, astronomers created gentle catalogs, quiet lists of worlds sorted by size, type, and distance. These early collections were small at first, containing only a handful of planets that stood out like rare gems. But as the years passed, the lists expanded, filling with hundreds, then thousands of entries. Each number represented a world with its own orbit, its own history, its own silent beauty. These catalogs help scientists compare planets, search for patterns, and understand how solar systems form and evolve. They are like cosmic field guides, offering introductions to places we have never seen but can imagine in soft, vivid detail. Turning their pages feels like opening a book filled with dreams and possibilities. And among the many tools used to study these worlds, one of the most elegant is the simple shape of starlight over time. Fact 92. The art of light curves. A light curve is a gentle graph that shows how a star's brightness changes moment by moment. When a planet passes across the star's face, the light dips softly, creating a smooth, rounded valley in the curve. Every wiggle and ripple in that line has meaning. The planet's size, its orbit, even the nature of its atmosphere. Some curves rise and fall like quiet waves. Others shift in subtle patterns that require patient study. Interpreting a light curve is like reading a poem written in starlight. Each shape reveals a little more about a distant world, and with enough careful analysis, the invisible becomes clear. These curves are the soft signatures of exoplanets, written across the stillness of space. And sometimes, when we're unsure what a world might be like, we turn to simulated realities for answers. Fact 93. Simulated worlds. Computers allow us to build gentle, virtual versions of distant planets, places sculpted from physics, chemistry, and educated imagination. These simulations can model weather patterns, atmospheric compositions, surface temperatures, and even how clouds might drift across an alien sky. By adjusting the inputs, scientists can explore many possibilities. What the planet might look like, how it might change with seasons, or whether it could host life. Though these worlds exist only in code, they help us interpret the faint clues we gather from telescopes. Simulated oceans ripple beneath digital suns. Clouds swirl through virtual atmospheres, and landscapes take shape from equations and data. These imagined planets bridge the gap between what we see and what might truly be. And sometimes, hidden in old data, new discoveries quietly wait their turn to be noticed. Fact 94. Messages from the past. Even after a telescope has finished its mission, its data continues to whisper secrets. Astronomers often return to old observations, discovering new planets hidden in the soft patterns of starlight recorded years before. A faint dip overlooked, a subtle wobble unnoticed, a tiny variation dismissed as noise. These details can later become the signatures of worlds we missed on the first pass. Reanalyzing archived data is like reading an old journal by lantern light, noticing small clues that once seemed insignificant. With improved techniques and fresh eyes, these forgotten signals come alive, revealing planets that have quietly circled their stars since long before we knew to look. In this way, the cosmos continues to surprise us, gently unfolding its mysteries over time. And patience becomes one of our greatest tools. Fact 95. The patience of discovery. Finding exoplanets is a slow, meditative process. Some stars reveal their planets quickly, dimming and brightening with regular, easy-to-read rhythms. Others take years, requiring careful observation through countless nights. A single planet might need dozens of transits before its presence becomes certain. Another may show only a whisper of a tug, a faint wobble repeated just enough to earn our trust. This patience is part of the beauty. Discovery becomes a steady ritual. Watching, recording, comparing, and waiting. Every confirmed planet is the result of quiet persistence, a reward for the gentle practice of paying attention. In a universe so vast, it takes time for distant worlds to make themselves known. And from this patient watchfulness, we begin to dream of the future paths humanity might take. Fact 96. Interstellar travel dreams. As we learn more about distant planets, it's natural to imagine someday traveling among them. Interstellar journeys remain beyond our current reach, yet the dream drifts through science and story alike. Tiny probes, vast ships, or even advanced sailcraft powered by light, each idea holds a whisper of possibility. These dreams are not hurried. They unfold slowly, shaped by curiosity and hope. If humanity ever ventures to another star, it will be toward one of these gentle worlds we've studied from afar. The journey would be long, perhaps spanning generations, but the vision brings comfort. A quiet ship gliding through the interstellar dark, carrying the soft glow of human wonder with it. And even before such journeys begin, smaller explorers may go ahead, drifting like seeds on cosmic winds. Fact 97. Robotic sailcraft. One of the most delicate visions for exploring nearby stars involves tiny robotic sailcraft. Spacecraft no larger than a postcard, carried forward by beams of light. These sails, thin as whispers and gleaming like floating petals, could ride streams of photons propelled by powerful lasers or the gentle push of starlight itself. Their journey would be swift compared to traditional rockets, gliding silently through the interstellar dark. Though small, these craft could carry sensors capable of capturing faint glimmers of distant planets. A quick flyby might reveal the color of an alien atmosphere or the presence of clouds drifting above an unknown horizon. Even without landing, these tiny emissaries could bring us breathtaking hints of faraway worlds. And as these sails drift outward, new observatories will remain behind, quietly watching the sky. Fact 98. Future observatories in space. In the decades ahead, new telescopes will unfurl in space like quiet blossoms of glass and metal. Some will float in perfect formation, separated by miles, yet synchronized with exquisite precision. Others will stretch wide, their mirrors capturing faint beams of ancient starlight with gentle clarity. These observatories will read planetary atmospheres molecule by molecule, mapping the compositions of distant skies with unprecedented sensitivity. From their calm vantage points above Earth's atmosphere, they will observe thousands of stars at once, searching for transits too subtle for today's instruments. They will measure temperatures, detect clouds, and perhaps glimpse signs of life's soft chemistry unfolding in distant places. These future observatories will become our cosmic lanterns, illuminating the darkness of interstellar space. And as they gather this delicate light, we will learn to read the weather of worlds we cannot touch. Fact 99. Learning to read. Alien climates. Every atmosphere tells a story of winds, clouds, heat, and quiet cycles that shape the surface below. By studying the colors of starlight filtered through distant skies, we can sense the presence of storms, haze, humidity, or even seasonal changes. A rise in certain gases might suggest summer on a far-off world. A sudden shift in light could hint at clouds forming or dissipating across an alien horizon. Scientists use models to decode these subtle patterns, recreating climates far beyond our reach. They imagine winds gliding through valleys, clouds drifting over vast oceans, and thermal currents rising from unknown surfaces. Even without seeing these places directly, we begin to understand their rhythms, the soft pulse of weather on planets light years away. And beyond all these discoveries, one last reflection waits: the quiet infinity of worlds that fill our galaxy. Fact 100. The endless ocean of worlds. When we step back and let the galaxy settle quietly in our mind, we begin to sense its true scale. A vast, shimmering sea, filled with planets drifting like gentle waves beneath starlight. Each one follows its patient orbit, moving through seasons and shadows, warmed by suns we will never feel on our skin. Some worlds glow with molten fire, others rest in icy twilight, and many more remain unseen, wrapped in the soft cloak of distance. Together, they form an endless ocean of possibility, stretching farther than any dream can travel. And in that ocean, we are simply one small shore, a quiet blue world circling a modest star, gazing outward with wonder. As we listen to the soft stories these planets tell, we are reminded that the universe is wide, peaceful, and full of gentle mysteries still waiting to bloom. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. Across 100 sleepy facts, we drifted through oceans of starlight and wandered past distant horizons, visiting worlds we may never see, yet can still imagine in soft, peaceful detail. If you enjoyed drifting through these sleepy facts, don't forget to like the video, subscribe, and comment below what topic you'd love to fall asleep to next. Your suggestions help guide future journeys, and they help other sleepy travelers find their way here too. When you're ready to keep dreaming, tap the end screen to watch the next Sleepy Astronaut video and continue your quiet voyage through the universe. Sweet dreams, and see you among the stars.